I say right foot creep, ooh, I'm walking with that heater. Look around, stay low, make sure they don't see you. Catch them bad, walk down, face them with the heater. The devil under your feet, you on your way to see him. Stretch me when I can't sleep, bang.
Welcome to Excelsior Education's Silver Day 5 greedy algorithms, not greedy. Okay, so what is a greedy algorithm? A greedy algorithm makes the best decision at every step and it uses the same thought process. So let's look at studying algorithms on code courses, which is going to be our example again. We're given X minutes bounded by 10 to the 4th and algorithms bounded by 100, and A, which is an integer, is the time required to learn said algorithm. Now the idea is to prioritize the least time in order to find the most number of algorithms that Steph Curry can learn. Right? Wow, good job for you, Steph, doing some programming. Okay, so here's some sample input. We're given 15 minutes to study 6 algorithms at most. What we're going to do is actually sort the array, which you should know how to do. Use arrays.sort. And again, since we don't need any retrieval, anything that's like big brain accessing, we can actually just use arrays. We don't need to use other data structures that we talked about in our last lecture. So you have 3, 3, 4, 4, 7, 8. So we can prioritize these, and we realize that hey, we get here 14. Try to add 7 to it. It's going to be greater than 15, so we stop our algorithm, right? Which stops this loop. But in the background, this count variable is actually counting, and that gives us the answer of 4 algorithms. So let's come over to the computer and check out what we have.
All right, so this is the template that I will link in the description down below. We're on studying algorithms, code forces, as we've discussed earlier, right? We know that our input is 2 space-separated integers and an x. So we have our fast reader, we have int n equals int next int, and we can also just copy this line here and replace it with x. All right, so now line 2 is going to be n space separated integers. So we're going to create an integer array called algos and new integer array. And of course I need to specify the size, which is going to be n. And then for int I equals 0, I is less than n, and I plus plus. What we're going to do is algos I is equal to in.next int, just like that. All right, now that our input's handled, let's write the algorithm, or take the one that's already on the website. So, as I've explained earlier, after sorting the array, you have this, maximum of 15, so the Steph can learn a total of 4 algorithms. And, of course, implementation is very simple. Sorting array takes O of n times log n time, and iterating takes O of n time, total time complexity of O n log n. So, we take this thing here, and we just copy that. So, what we're going to do is arrays.sort, and we're going to put in algos. Alright, and that would sort the array. This takes in algorithm input, and this takes in time and size input. Okay, so now that we've sorted the array, we could just use a for loop in this case. So we have, let's count the number of minutes used so far like they did. Int count is 0, int I is 0. I'm just going to copy them exactly and then edit it afterward. So use that. All right. And There we go. Okay, so while I is less than n and count plus algos, this is algos because we changed the name. There we go. Is less than or equal to x, which means that there's enough time to learn an algorithm. And this essentially just adds the next one over. If I were to write this as a for loop, I would do for, use that template there, for I equals 0. I have to make sure that count plus algos I is less than or equal to x, and then do I plus plus. And you can essentially just put this exact same code there, saving us a bit of space. And of course, let's just move that there. All right, so there's enough time, learn more algorithms, and this just adds to our time count. So now, what do we print out? We print out the answer to the problem, which is the number of algorithms, right? Find the maximum number of algorithms she can learn. So let's check that. And F plus, all right. And of course, I here, I see. They use I in the while loop as a counter. So I only increments when you have the correct, I guess, number put into algos, which is actually really smart. Okay, never mind. We actually don't need to use a for loop. But since we've already done this for loop, might as well have another one. So we can change that to count, and then this is count 2, and then we can always just increment count 2. There we go. And then system out dot println count 2. All right, and that should be it for this algorithm. And I'm going to comment this again. Prints number of algorithms learn that Steph can learn. All right, so this should automatically save. There's probably no error here. Oh, other than the fact that the name is template and not studying algorithms. There we go. Anything else? Probably not. Right. I need to make sure that there is a fast reader, so fast reader in equals new fast reader. There we go. All right, let's go to code forces and Java. Choose a file, not those files, but these ones. Studying algorithms. Submit, and we shall see wrong answer on test case 1. Oh wait, that's a different problem, right? Different day. Yeah. Okay. Different problem, different day. All right. Looking at this one here. Runtime error on test 3. Probably because we're using Java. Okay. Well, since this thing doesn't want to, actually let's check my submission, see, is it gonna tell me like exactly what passed? Like, okay, it's not gonna tell me what passed. So what I'm gonna do is actually just do this problem in the terminal. So we're gonna use run Java, allow access. All right, so we're gonna put in the numbers ourselves. We have 6 and 15, and we have 4, 3, 8, 4, 7, 3. And the answer should be 4. So, algorithm works.
Welcome back. So, example 2 talks about bad greedy, which means that you think about the decision-making process and it's kind of counterintuitive. So you need to really think deep and see if it works for every test case, right? So an example of a bad greedy algorithm is in this problem here. We have n events, and you must attend the maximum of events, right? Number of events, but you have to attend the entire event. So a bad greedy algorithm, what it would do is just look at the starting time of the event. Oh, okay, but what if there's this huge event? You take this one event, and the output's gonna be 1, because it's not gonna check these at all. So that's a bad greedy algorithm. A good greedy algorithm actually checks the end time of each event and looks at the one that's closest to our present time. Of course, we're gonna have to keep track of our present time here. And again, if this sounds very familiar to you, this is actually a type of problem that's called simulation, right? Where again, you would have learned this concept in USACO bronze. I will make a bronze series eventually, after I get my silver medal. Anyways, so let's come over to the computer and check out how we code this good greedy algorithm.
Alright, so let's tackle Movie Festival. So, again, we use our template, right? And we copy a bit of code from USACO.guide, where, again, they have static class event, and it makes a whole fancy class of events. Technically, you could also, just use multiple arrays, but this is a very clean approach. I approve. Very nice. Anyways, they have a little class that implements comparable event, where again you have a little compare to, right? And it's a new data type where you can essentially have S and E and you can compare them. You compare actually the endpoints of the event, where this .n represents the event that's put into the compare method. And again, we can see this in their code where they use arrays.sort first to sort for the comparator. Current event end, okay, it has to be -1. An event they're currently attending, because the first event can start at 0. How many events were attended? That's going to be our answer. Process events in order of end time, right? So again, for loop through the events array. If the starting time is greater than the current end, so if you can attend that event, then we know that this is the earliest ending event that we can attend because of how events are sorted, right? Then what we do is current event end, right, which is after the event we've just attended, equals events dot end. And essentially what that does is show you, or set the event end to the current time, or to the time of the to the end time of the event that we've just attended. So this is sort of like simulation as well, which is another bronze concept. And we do ands plus plus because we've attended an event, and that's incrementing our counter, and we print out our answer. So the code that I put in was the fast reader, right? We know that n is in.nextInt here, and then we have event array events. I wrote that as well. And then the input is going to be 2 in.nextInts. So let's see if this code works. Submit movie festival and Java. We submit it, pending, and boom, all correct. Thank you.
All right, let's talk about cases where you don't use a greedy algorithm. Example 1 is we're given a set amount of points, and we want to find the smallest amount needed to have a certain value. So this works in specific cases, like US dollar or the euro, right? But if we're given a custom denomination, let's say a coin that has a value of 1, 3, and 4, and we want 6. Now the optimal pairing is 2 3s, right? But if we use a greedy algorithm that looks at the highest coin value first, which seems very intuitive, you pick the 4, pick the one twice, and that's going to be the answer, which is wrong. Now, from my experience, what I would do is use backtracking, but we haven't learned that yet. So we'll get to it when I do my bronze series or my gold series, whenever we get there. Example 2, we're given an item that has a certain weight and value, and we have a limited weight. We want to maximize the value that we get. So let's say we have items A, B, and C, right? Here's weight, value, and value per weight. If we use a greedy algorithm on the highest value or value per weight, it's just going to find A, right, with this number 6 and just quit, which isn't the correct answer. The correct answer actually involves dynamic programming, which we'll tackle in our gold series if I do make that. Alright, thank you for watching Silver Day 5. See you next time.